Okay, welcome to the first video on solving higher degree equations. The book kind of divides different techniques here for doing this into several different sections. We're going to do every one of these techniques we did last year in Algebra 2. We will just be expanding them, kind of reviewing them, and obviously the problems are going to throw a few more curveballs at you, try and trip you up a little bit. Okay, we're just going to talk about polynomial equations. We've already talked about that a little bit. Solving a cubic with no constant, we'll talk about that. Solving a cubic by factor by grouping, okay? And then solve a polynomial in quadratic form. We'll go through all of those and what they mean, okay? First of all, a polynomial equation, okay? Poly meaning many, nomial numbers. Okay, something like this, like x, and we're going to deal with a lot of cubics here in this section. So x cubed minus 3x squared plus 7x minus 1 equals 0. And the reason we set things equal to 0 is because what we are trying to do is find the zeros, which again, just to reiterate, is every place that this thing crosses the x-axis. I want to know what those points are. Those are the zeros. So the whole point of this video will be to find those points. Okay, here we go. Solving a cubic with no constant. Now we all know the constant is the number at the end. We don't have one. This is plus 0. There's no constant there. So the first thing you're looking for when you solve any of these equations is, can I factor anything out? Can I factor anything out? And in this case, is there anything common in all three of these terms? There's a 2x here. I can factor a 2x out of this and a 2x out of this one. Okay, so if I factor a 2x out of both, which just means I'm doing the distributive property backwards, this is going to leave me with x squared plus 3x plus 3. And that's going to equal 0. Okay? Because if I distribute 2x back through, I should end up with the same thing I started with up here. Well, 2x times x squared is 2x cubed, so we're good there. 2x times 3x is 6x squared, and 2x times 3 is 6x, so we're in good shape there. Now, this leaves me with, and I'll rewrite it, 2x times x squared plus 3x plus 3. Now, we just went through several ways last week of solving a quadratic. Well, guess what I've done for myself here? I have made this piece into a quadratic. So let's look at that and see, does it factor? Does this quadratic right here factor? And if we're looking at it, what are the factors of 3 that are going to add to 3? And there are none. 3 plus 1 is 4. Those are the only factors. So I'm going to have to do something else, like the quadratic formula. So what I do here, since this won't factor, I'm going to take this piece and set it equal to 0. So 2x equals 0. And then I'm going to take my second piece, we'll do it over here, x squared plus 3x plus 3, and set that equal to 0 and solve each one. Well, this one up here, if I divide by 2, x equals 0. So that's one answer. So we're in good shape there. Now I need to solve this one. Well, I'm not going to complete the square because this is odd. Okay, and it's just going to deal with fractions. So I'm going to use the quadratic formula. Negative b, which is 3, plus or minus the square root of b squared minus 4ac all over 2a. And now we're going to go ahead and solve this. So negative 3 plus or minus the square root of 9 minus 12 all over 2. So negative 3 plus or minus the square root of negative 3 all over 2 Well, negative under a radical there, that means I'm going to have imaginary numbers. So it's negative 3 plus or minus I root 3 all over 2. And if this is confusing here, here's what I did. I took the square root of negative 3, made it the square root of negative 1 times the square root of 3. Square root of negative 1 became I. Square root of 3 is still the square root of 3. So here are my other two answers. They're imaginary, but they're my other two answers. How many total did I need? Well, if I go back to the very top, this was a cubic. That means I need 3 answers. Here's 1. And here are the other 2 because it's plus or minus. 3 plus I root 2, or root 3, over 2, and 3 minus I root 2 over 2, and then obviously the other one was 0. Okay? They're solving with no constant. And what was the thing I did right away? I factored out whatever was common there. Okay? And we'll work more examples with this in class when you guys get here. Okay? Let's move on to the next thing. Factor by grouping. Did this a lot in Algebra 2. Okay? Did this a lot in Algebra 2. We're going to go through the same process we went in the last one. I look at it. It's a cubic. It's not a quadratic. Okay? So the first thing I'm going to look for is there anything I can factor out of both? Or out of everything. Not out of both, out of everything. Well, I can't factor an x because there's not an x in the 20. And we got a 1 here, 5, 4. There's no common factors that I can factor out. So the next thing we try is factor by grouping. And I take this piece, and I see what I can factor out of this piece. And then I take the next piece, and I see what I can factor out of there. Okay? Well, if I take the green piece, what can I factor out of this? Well, I could factor out an x squared. So I have x squared. And if I'm doing the distributive property backwards, that leaves me with an x plus 5. Now, if I redistribute this back in, that would give me x squared times x is x cubed. And x squared times 5 is 5x squared. So everything works out. Okay? Now I'm going to look and see what I can factor out of the red piece. Well, I can factor out a negative 4. I can see that, and that leaves me with x plus 5. Now, why is it plus 5 here? Because I got a negative here and a negative here. I factored out a negative 4. So if I multiply negative 4 back in by 5, I get negative 20. Okay? And this equals 0. Now we're going to do a little trick we use in calculus all the time. Okay? Notice, I have an x plus 5 here and an x plus 5 here. So we're going to do the w trick. And I showed you this in Algebra 2 last year. But since I have that thing happening twice, I'm going to say w equals x plus 5. And now I use w for me to simplify the problem. We're going to have to substitute w out when we're done. But everywhere I see an x plus 5, I'm going to make a w. So x squared times w plus negative 4 times w equals 0. Okay? Now, what's common in both of these? Well, a w. So I have, if I factor that out, I end up with w times x squared plus a negative 4 equals 0. Right? All the w's come out. Now, I've got it down to a multiplication problem. And I've got this piece down to a quadratic. I can now solve it. So if I take each piece and set it equal to 0, I have w equals 0. And I have x squared plus negative 4 equals 0. Well, I don't care about w. I care about x. So I'm going to substitute the x plus 5 back in for w. So I now have, let's do this, x plus 5 equals 0. And if I solve that, x equals negative 5. Right? Well, there's one answer. Now I solve this one. Okay? Add 4 to both sides. X squared equals positive 4. Take the square root of both sides. X equals plus or minus the square root of 4. So x equals positive 2 and x equals negative 2. Well, how many answers are they supposed to get? It's a cubic, so there's 3. And here they are. I have x equals negative 5, x equals 2, x equals negative 2. Okay? There is that. All right? I've got one more case to deal with here. Solving a polynomial in quadratic form. Now, why is this in quadratic form? Because I go from x, if I look at a quadratic, x squared plus 2x plus 1. Okay? The reason this is in quadratic form is because it's two terms, and the power is decreased in half every time down to 0, down to a constant. Okay? So, here's why this is handy. First thing we do is the first thing we did on every other one. Is there anything I can factor out of that to make it easy? Obviously a 2. I can't factor an x out because there's nothing over there with the x. But I can factor out a 2. So that leaves me with x to the 4th minus 4x squared minus 45 equals 0. Okay? Now I'm looking to see if this piece in here factors. And it will, and I'll show you how this works. This is 2 times x to the 4th and x to the 4th. Well, I can break that down into x squared times x squared. Because, look at my middle term. It's x squared. So when I add up, when I FOIL, I'm going to get up with x squared as my middle term. So what are the factors of negative 45 that add to negative 4? Well, that's going to be negative 9 and positive 5. Because negative 9 times positive 5 is negative 45, and negative 9 plus 5 is negative 4. So now I've made everything multiplication. Well, now I've got to get rid of this 2. So if I divide both sides by 2, 2's cancel on the left. 0 divided by 2 is just 0. How's my time going here? Oh, we're in good shape. So I'm left with x squared plus 5, x squared minus 9 equals 0. Well, now I take each piece just like I would with a normal quadratic and set it equal to 0. So x squared plus 5 equals 0, and x squared minus 9 equals 0. And I solve. X squared equals negative 5. X equals plus or minus the square root of negative 5. So x equals plus or minus I root 5. There's 2 of my answers because it's plus and minus. Now let's solve this one. X squared equals 9. X equals plus or minus the square root of 9. So x equals plus or minus 3. Okay, so here are my answers. X equals I root 5. X equals negative I root 5. X equals 3. X equals negative 3. That's 4 answers, and how many was I supposed to get? Well, it's a quartic, so I'm supposed to get 4. Okay, simple enough. Hopefully, all this was review with how we solved all of these. Cubic with no constant, factor out an x, factor by grouping, and factor in quadratic form. We're going to work a ton of examples in class. You may need to rewatch this just because I went through some of the algebra kind of fast to kind of grasp what we're doing. But hopefully this is review. I know you've seen all this in Algebra 2, so hopefully this isn't too much of a stretch to wrap your mind around this again. All right, we'll see you in class.